Welcome to the third past paper run through. As ever, the 6-mark questions won't be answered in this video because they're a bit too complicated, but you need to see your teacher at the end of this to get the 6-marked questions mark schemes. And always remember that there's this list of equations at the front of your paper. If there's any question with numbers in, especially in the physics section, then make sure you refer to this page just to see if the answer is in there. So, first question. It says, Joe grows a broad bean in a jar. The bean starts to germinate. Which part of the seedling is part X? So you can see the part X is growing downwards, so that is the root. And then Y is part X growing this direction. So you could say it's towards gravity, or to get water, or to get minerals. You could say it grows away from the light. You could say to get nutrients, but you can't say food. And then explain why part Y grows upwards, and that's towards the light, or for photosynthesis, or to make food. You could say because it's a shoot, that would get you a mark as well. And then as the broad bean germinates, each new cell has 12 chromosomes in its nucleus. Explain why a broad bean seedling needs chromosomes, and that's to carry the genes or carry the DNA, or to control characteristics. You could put to make proteins as well, to get a mark there. Then how many chromosomes will be in the nucleus of a broad bean gamete, or sex cell? Remember, the sex cells of any organism has half the number of chromosomes as the whole thing. So that answer would be 6, because there's 12 in the whole thing. Joseph Merrick lived in England in Victorian times. He was sometimes known as the Elephant Man because of his physical features. There he is. At the time, some people thought that Joseph's features were caused because his mother was frightened by an elephant while she was pregnant. Is this a scientific explanation? Well, that's no, but you don't get a mark for that no. You get a mark for these other points. So you've got to say something like that the physical features are affected by genes, and there's also that there's no evidence for the claim that is made in this question. So you could say no. The first mark probably is better to say there's no evidence, and then you've got to explain in science what actually causes Joseph Merrick to be like that, and the physical features are affected by genes or inheritance. You could say disease as well. So first mark is saying that there's no evidence, second mark is saying what actually causes it. Next question. Nowadays, scientists think Joseph's physical features might have been caused by a combination of several disorders, one of which is neurofibromatosis. One effect of neurofibromatosis is damage to the peripheral nervous system, causing numbness. Where in the body can the peripheral nervous system be found? Put a ring around each correct answer. So there's 2 here. It's the muscles and the skin. You have to have both of them for that 1 mark. It says, what type of neuron in the peripheral system would be damaged to cause numbness? And that's a sensory neuron. In his later life, Joseph also suffered from bronchitis. In bronchitis, extra mucus is produced in the lungs. The extra mucus is removed by coughing. It is normal for some mucus to be produced. What is the function of mucus in the lungs? So you get 2 marks. First mark for saying trap or catch, and the second mark for saying what they're catching. So you can say pathogens or bacteria or viruses or dirt or dust. So 2 marks for both of those. If you said trap germs, that'll get you both marks, for example. And then the next question, there are several causes of bronchitis, one of which is smoking cigarettes. Draw straight lines to match up each substance in cigarette smoke with its effect. So carbon monoxide causes a lack of oxygen, nicotine is the addictive part, and the tar causes cancer. If you got either 1 or 2 of those correct, you get 1 mark, and if you get them all correct, you get both marks. Next question says, look at the BMI chart. And it says BMI is calculated using the formula. There's the formula. This can be rearranged to give the formula that, which gives you the mass in kilograms. Instead, it's rearranged. And it says Bob's height is 1.8 metres, 120 kilograms, and his BMI is 37. Calculate the least mass he needs to lose to fall into the normal category. So the least mass you'll have to lose will make him normal, will give him a BMI of 24.9. So what we've got to do is put that BMI into that formula and first work out what mass he has to be that BMI. So the mass would equal 24.9 BMI times the height in metres squared. And that gives you 80.7. then that's the mass he has to be. The mass he has to lose will be 120 minus 80.7, and that equals 39.3. So it's 4 marks for that. That's quite a tricky question. So you get 1 mark for that bit, 1 mark for that bit, 1 mark for that bit, and then 1 mark for that bit. So the chemistry section. So this question is about food additives. Chloe uses a cake mix to mix a cake. Some of the ingredients in the cake mix are listed below. Chloe adds oil, eggs and water to the cake mix. Emulsifiers and flavour enhancers are food additives. Draw a straight line from each food additive to its job. So emulsifiers, they help oil and water to mix and not separate. They keep oil and water together. And a flavour enhancer will improve the taste of the food. Baking powder helps the cake rise. Baking powder contains sodium hydrogen carbonate. Write down the number of elements. Now for elements, all you have to do is count the capital letters in a molecule. So there's 1 there for N, 2 for H, 3 for C, and 4 for O. So there's 4 different elements in sodium hydrogen carbonate. And then Chloe thinks that carbon dioxide is given off when sodium hydrogen carbonate is heated. Describe how Chloe can show that the carbon dioxide is given off. So first mark is saying using lime water, and the second mark is saying that lime water will go cloudy, or you can say milky or chalky. So yeah, 2 marks there. Crude oil, coal and natural gas are fossil fuels. These fuels are non-renewable. Explain what is meant by non-renewable. So first mark is saying that they take a long time to form, or they take thousands or millions of years to form. And the second mark is saying that they are used up faster than they are formed, or they cannot be made again, or they can't be replaced. We would also get that mark. Crude oil is separated into main fractions by fractional distillation. The diagram shows a fractionating column. There it is. It says, look at the table, it shows the boiling point range from the fractions. Write the name of the fraction which exits the bottom of the fractionating column. Now to remember this, you can remember that it's in a fractionating column, it's hot at the bottom and it's cold at the top. So the fact it's hot at the bottom means that the one with the highest boiling point is going to come off at the bottom, which is bitumen. So the answer to this is bitumen. LPG contains propane and butane. Write the number of atoms in a molecule of butane. So that is actually counting each of the symbols. So you got 1, 2, 3, 4 carbons, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. So that's 14 overall atoms. And then look at the displayed formulas of propane and butane. Propane and butane are hydrocarbons. They're also alkanes. Explain why they're both hydrocarbons and alkanes. So if you start with hydrocarbons, that is that they contain hydrogen and carbon. That's the first mark. Second mark saying only hydrogen and carbon. And the third mark is saying that they only contain single bonds. And that's explaining why it's an alkane. Alkanes only have single bonds. Alkenes have at least 1 double bond. This question is about car engines. Car engines make carbon dioxide. Look at the table. The table shows the amount of carbon dioxide emitted by 5 cars. Henry wants to buy a car. Henry finds out that car tax is not paid on cars with carbon dioxide emissions lower than 100 grams per kilometre. Henry would have to pay car tax on some of these cars. Which cars? So the ones that basically have carbon dioxide emissions less than 100 are the ones you wouldn't have to pay car tax on. That's C and E. So you've got to have both of those for that mark. And then many car engines burn petrol. Petrol contains octane. Octane reacts with oxygen. Carbon dioxide and water are made. Write a word equation. Remember, when we're writing a word equation, draw an arrow first. Then we have things that are reacting together on the left of the arrow. So it says octane reacts with oxygen. And then put what are made. So it tells you carbon dioxide and water are made. And you make sure you put pluses in between each of the reactants and each of the products. This question is about polymers. Jill wants to buy a sports jacket that she can wear in all weathers. Look at the information about polymers A, B, C, D and E. Which polymer would be best for making Jill's sports jacket? Explain your choice. So you must say first C, but that won't get you a mark. To get the 2 marks, you've got to say because it's flexible, waterproof and breathable. All those 3 things for those 2 marks. Ethene is used to make a polymer. Write down the name of this polymer. So remember, you need to put ethene first, and then to make it into the polymer name, you simply write poly before it. Polyethene. Next question says, the picture shows 2 feeding bottles for a baby. These bottles have been painted with a special paint. This paint contains a thermochromic pigment. Explain why this paint is being used. So there's 2 marks for this. So first mark is just explaining that thermochromic paints change colour when they're heated or cooled. And then the second mark is saying that the colour of the paint will show that the milk is the right temperature. Or you could say that it'll allow you to see if the milk is warm or cold. Or you could say that it'll allow you to see if the milk is safe for the baby to drink. So on to the last section now, the physics section. So it says, Grace researches methods of loft insulation for a house. Look at the information she finds. There's information, so suggest which material is the best insulator and explain your answer. So the best one is going to be the one that you need the least of to stop the heat. So recommending thickness of insulating material in millimetres. So the one we have less of is spray foam. So spray foam, we get the first mark, and then the second mark is just saying that it has the lowest thickness, or it's the thinnest. Then Grace thinks she can improve her loft insulation. She uses a layer of shiny aluminium foil under the insulation material. Explain how shiny aluminium foil can improve her loft insulation. So it's just the idea that this reflects heat, or reflects energy, for that mark there. So reflects heat is the important word there. Next question, this question is about waves. Wireless technology uses electromagnetic waves. Look at the names of the waves in the electromagnetic spectrum. What can you say about the speed of these waves in a vacuum? So basically they're just all the same speed for that 1 mark. Then write down 2 uses of infrared radiation. So 2 of any of these, say remote control, telescope, automatic doors, photography, heating or cooking, sensors or burglar alarms, games consoles or the Wii. Or you could say heat treatment for sports or muscle injury. So any 2 of those. Wireless technology has no external wiring. Write about the advantages of this. So 2 advantages you need. So any 2 of these, you can say it's portable, you could say it's convenient, or you could say you can access devices when you're on the move, or you can connect using Wi-Fi. You can also say that it can be used in many places or anywhere in your house. Surfers use water waves on the sea to move fast. Look at the diagram of the water waves on the sea. There it is. So the surfer travels at the same speed as the water waves. The water waves have a frequency of 0.25 Hz. Use the information in the diagram to find the wavelength of the waves and calculate the speed of the surfer. So remember to look at, there's numbers here, physics section, look at the front page, and you'll find on the front page that the wave speed equals frequency times the wavelength. Now the wavelength here is actually half of this distance, because there's 2 waves in this distance of 40 metres. So it's going to be 20 times 0.25, which is 5 metres per second. If you just times that distance by 0.25 and got 10, that would get you 1 mark instead of the 2. Next question says, Dave experiments heating different materials. He needs to choose a heater to warm some water. The table shows how much energy different heaters supply in 600 seconds. It says Dave needs to increase temperature of 0.6 grams of water by 12 degrees in 600 seconds. Water has a specific capacity of 4,200. Do a calculation to find out which heater Dave needs and show your working. So you've got to remember that energy equals mc delta T, and that's in the front of your booklet. So it's mass times specific heat capacity times the temperature change. So you need to work out which one of these Dave needs. So you can put in 0.6 for the water, that's the mass, times that by specific heat capacity, which is 4,200, times that by the change in temperature, which is 12, and that equals 10,200. Sorry, no it doesn't. it equals 30,240, and therefore the heater he needs is E, because D doesn't release enough energy, so E does. Next question says, Dave needs to boil some ethanol. He used an electrical heater. Look at the diagram. So if the ethanol is at its boiling point, Dave measures the temperature of this ethanol as it boils. What happens to the temperature as it boils? You just say it stays the same. Remember, when something's freezing or boiling or melting, the temperature of it stays the same. And it says the specific latent heat of ethanol is 850 joules per gram. Calculate the energy needed to boil 12 grams of ethanol. That's simply going to be the latent heat, 850, times the mass, and in this case is 12. That equals 10,200, and you've got to put the answer to get both those marks there. So 10,200. It says, when Dave does the experiment, he finds that he needs more energy to boil the ethanol than expected. Suggest why. 2 marks, so you can say that there's energy needed to heat the beaker, or you can say he's also heating the air or the surroundings. Or you can, there's the idea that if you look at the diagram, part of the heater up here is not in the ethanol. So you could also say that for that mark. Then the last question says, in 2011 there was a major earthquake in Japan. This was followed by a devastating tsunami. Scientists did not predict this earthquake accurately. Immediately after the earthquake they did predict the tsunami. Explain why the tsunami was predictable. And for that 1 mark it'll say that the tsunami is caused by the earthquakes and therefore is predictable. And then last question says, scientists are getting better at making predictions. Suggest what scientists could do to improve their monitoring of earthquakes. And you could say, for that 1 mark, any of these points, you could say that more data is gathered. You could say we're able to process more data now. You could say we have more sensitive equipment or better equipment. Any of those 3 points would get that 1 mark. Before you leave, remember to get the next paper, then that's to be completed after Easter, and the 6 mark question mark scheme from the teacher.